Infinity. Infinity is a very complex topic. This is because it deals with numbers so big that we can barely comprehend them. The reason infinity is such a hard concept to grasp is because it goes against everything we have previously learned about math. Such as basic counting, think about it. Is the difference between 1 and 100 greater than the difference between 1 and 10? Normally, we would have said yes, but in the case of infinity, they're the same. Infinity is not a single categorization of numbers. Infinity can be applied to any pattern or categorization of numbers. And because there are so many ways to categorize numbers, there are many different ways to categorize infinity. For example, prime number infinities, even number infinities, odd number infinities, imaginary infinities, and so on.
Not all infinities are the same size. For example, fractional infinities are smaller than decimal infinities. You can prove that decimal infinities are greater than fractional infinities in a simple way. By making a table like the one we're making now, you can prove that you can list every single fraction. The reason decimal infinities are greater than fractional infinities is because you cannot list all the decimals. The reason you can't list all the decimals is because for any list of decimals, there can always be a decimal produced that is not on that list. In order to do this, you simply look at the first digit of the first number, and if it's even, write an odd number, and vice versa. Next, you look at the second digit of the second number. If it's even, write an odd number, and if it's odd, write an even number. You can repeat this process as many times as there are numbers on the list. At the end, you will have produced a number that is not on that list. Infinity introduces many new and interesting ideas, such as the concept that there are the same amount of even numbers as there are whole numbers. This is true because there are an infinite number of real numbers, and since even numbers make up a part of all real numbers, they also go to infinity. To better understand infinity and the concepts that go with it, let's propose a metaphor. Let's say that you have infinite bags that can only hold one ball each, and each bag is full with this ball. Then you wanted to add a ball. Where would it go? In order to solve this problem, you must first remember that infinity goes on forever. And although it is very hard to imagine it, there are always more numbers. So you would simply move the ball from bag 1 to bag 2, and the ball from bag 2 to bag 3. You would move every ball from bag n to bag n plus 1, freeing up bag number 1. So, in conclusion, the concept of infinity is a huge topic that is very hard to understand, but it is also very interesting and unlocks many key pathways of math.
The reasons we decided that we wanted to explore the concepts of infinity were that it sounded like a really cool and complex topic. We went into it thinking that it wouldn't be that hard to understand, but we quickly realized that the various ideas surrounding infinity were very complex. It was very intriguing to find out that different infinities could be different sizes, and especially that in terms of infinity, there are the same amount of even numbers as there are whole numbers. Another extremely interesting thing that we learned was how math with infinities worked, where you can add 1 to infinity and it would still be infinity. All in all, this was a very eye-opening project, and I'm glad we chose the subject we did.